Thanks everyone for joining us. My name is Mike Aldis from MPA Mott Consulting Engineers. As you can see, I'm not Marloes. I'll be standing in for her today. Unfortunately, she's on a flight back to Joburg. So just a short summary on what we're going to be looking at today. So the webinar is going to introduce sustainable urban drainage systems, or SUDS as they're more commonly referred to, used in South Africa for stormwater management. So if you've ever wondered how stormwater can be managed in a sustainable way, this is definitely the webinar that's going to try and unlock that. We've managed to pull together some expert speakers in their field, and this is definitely an area where we've seen a growing interest over the years. It's been one of those areas that's been forgotten for a very long time and always been on the back burner. I think there's been a lot more focus on the building side, the energy side, but sustainable urban drainage is becoming more and more prevalent if one looks at the havoc that water can wreak. So we're going to look at how it's been implemented in different South African cities, the benefits for both property owners and the environment. And we'll also showcase some real-world examples of projects where SUDS have been successfully implemented. So I encourage you to sit back and take it all in. Then moving on, who we are as the Regenerative Collaborative SA, a non-profit organization focused on transforming our built environment into a regenerative one. So based on that, I think I always encourage you to reach out through our social media channels, etc. And if you have interesting projects, if you have any sort of sponsorship opportunities, feel free to let us know. So yes, we've got the YouTube channel. So this will be posted on YouTube as just a reminder. And then again, just to keep an eye out on all the social media channels for the Regenerative Collaborative. So probably the most important slide, and that is our sponsor. Each session is sponsored by a company that's willing to help drive the regenerative agenda. And this month we have Geoplast. So I'm going to give you the Geoplast introduction. So before we dive into the SUDS presentation by our speakers, I want to take a few minutes to introduce you to the webinar sponsor. Geoplast, since its foundation in the early 1970s, Geoplast has been designing and manufacturing innovative recycled plastic products. They create sustainable solutions with high added value that offer excellent performance and useful life cycle in line with construction industry standards. Year after year, they have improved their expertise in the strategic sectors, which include construction, stormwater management, urban green, and landscaping. They're distinguishing themselves as a reliable and efficient partner. Geoplast products are available worldwide thanks to an extensive network of distributors, including 2 subsidiaries in South Africa and the USA. Geoplast firmly believes that the environment and industry can coexist and support each other. This has been our main motivation since the foundation of the company. Almost all of our products are made from recycled plastic from post-consumer and industrial scrap. This way, waste material is transformed into valuable resources and ultimately into new intelligent applications. Their portfolio includes solutions for formwork, water management, green building, and sport facility construction. The company focuses on creating innovative and sustainable products that contribute to reducing environmental impact and improving construction efficiency and safety. Geoplast Global emphasizes eco-friendly practices and aims to revolutionize the building sector through the use of recyclable materials and smart design. As a vision and mission, their vision is a world where construction actively supports regeneration rather than contributing to resource depletion. Geoplast's mission is to drive this change by offering sustainable alternatives that outperform outdated materials and methods. They want to help us build better, greener, and smarter. The increasing precipitations combined with the growth of urban impervious surfaces are highlighting the need of efficient and sustainable stormwater management solutions. Geoplast offers several such solutions suitable for different specific requirements. Geoplast has developed a wide range of solutions capable of responding to specific needs based on project requirements. On the water management side, Geoplast offer a range of modular systems for rainwater collection, storage, and infiltration. Draining is one of our products for rainwater drainage. It is suitable for irrigation accumulation, draining, and disposal of rain or wastewater. Draining prevents flooding by slowing down the discharge of rainwater in urban areas. On the green infrastructure side, Geoplast solutions enable green roofs, permeable pavements, and other green systems that mimic natural filtration processes. Their geograss and run floor systems, for instance, reinforce grassed areas or create permeable surfaces for driveways and parking lots, allowing water to soak back into the ground. Product-wise, traditional concrete structures have their place, but Geoplast recycled plastic systems offer incredible long-term durability, often outlasting traditional materials. This matters for SUDS because it means less maintenance and fewer replacements over time. On the bigger picture, beyond specific products, Geoplast's commitment to sustainability aligns perfectly with the purpose of SUDS. Smart water management is crucial for building resilient, eco-friendly cities. By collaborating with companies like Geoplast, engineers, architects, and urban planners have the tools to create communities that thrive in balance with the natural environment. As a call to action, I encourage you to visit Geoplast's website at geoplastglobal.com for detailed product information and case studies. So having looked through the information, there's a wealth of knowledge that's available there, and I think it's incredibly useful to everyone on this call to download the catalog, have a look through it. I think there's a very broad cross-spectrum of applications where there's potential synergies with a number of projects you may be looking at or may even be working on. So once again, thank you very much to Geoplast as our sponsor for this session. And then moving on to our speakers. First speaker up is Motlatsi Monyake. Motlatsi Monyake is a candidate civil engineer registered with the EngineeringCouncil of South Africa. He holds an MSc Eng and a BSc Eng honours from the University of Cape Town in SA. In this time, he was also afforded an opportunity to co-supervise the UCTBSc Eng permeable interlocking concrete pavement, or PICP research. His master's research entitled Clogging in PICP contributed substantially to the development of the PICP Guidelines in South Africa. He is the co-author of the first guidelines for the design, construction, and maintenance of PICP in South Africa. And just going beyond that, I'd like you to, there is an EMESA article that goes into some of the details. And I think for those of you that are technically minded or want to get into the nuts and bolts of it, it's definitely a good batch of research to delve into, particularly on the PICP front, which has generally been fairly limited with a local contextualization. So Motlatsi, thank you very much for making yourself available. And then Henk Breunissen. Henk Breunissen is co-owner of Orange Waterworks.nl and owner of happyfeetsports.com. He is driven to design and build water retention solutions custom-made for buildings, gardens, parks, pavement, and sports fields all over the world, with the main focus on South Africa and the Netherlands, offering sustainable solutions for global issues as water management and heat stress in cities, and in alignment with the Sustainable Development Goals. So again, another fantastic speaker with some local context and some international experience. So we'll start with Motlatsi, and then we'll go straight into Henk's presentation. Thank you very much to both our speakers.
Thank you for the invite, the organizers of this incredible webinar, and also the attendees. My name is Motlatsi Monyake, and I will be taking you through quite an interesting research we conducted with my professor while at UCT, Professor Neil Amitesh. So the research was entitled Clogging in PICP, which is permeable interlocking concrete pavement. And then you realize that it contributed quite substantially to the considerations for the design, construction, and maintenance of PICP in South Africa. So this slide, Mike shot before me, so you have seen it. However, just to add on this, so currently I'm working for a consulting firm situated in the Gauteng region. So I think that is what was left. So the details of the presentation, I will take you through the effects of urbanization that it has, because we know that we want to introduce some developments in our urban areas, but then it has some impacts and negative impacts as well on how it impacts our stormwater management. So I'll take you through to what is PICP and also the state that we discovered when conducting this study of PICP in South Africa, and then understand the core findings of the study, which is the PICP failure mechanisms. Then we'll take you through to some suggestions, or rather recommendations, that we would like you to consider when you design, construct, and even maintain PICP. And then lastly, we'll take you through just show you how you can find our PICP guidelines, which also have the research report. So taking you straight in, so you can see that you have this edge to develop areas. However, while developing areas, we introduce some impervious surfaces that end up creating high runoff after the construction. While before construction, in a greenfield area, you find that water is just infiltrating into the groundwater, and then we are not really imposing any negative impact on the receiving water bodies. So as stated, urbanization changes the perviousness of the ground, changing the hydrology of the system of that site. So as you can see here, this picture, I hope you can see my cursor, you realize that during the pre-development time, you have a very low peak runoff, and then when you start developing and start to introduce these impervious surfaces, you start having a high peak, and also it even peaks faster, which is why you have high runoff factor in that area there. And then I'll take you through to the challenges that you face during conventional stormwater management. So you see that you have some vegetation or some leaves that just find their way into the system of the groundwater system of conventional stormwaters, which you know that it talks about some groundwater conduits or pipes that Mike showed earlier on, even though it was a different technology, but you have underground pipes. And then because of the imperviousness, you have high volumes of runoff generated, and then you have a high rapid flow rates, and which will end up causing destruction and also eroding infrastructure. And then in some low points, you end up having flooding. So this, you realize that it compromises the biodiversity in the areas where there is high rainfall, and also it creates a problem to the amenity of the sites as well. So let alone the quality of the sites, as you can see in this top right picture. So it's important that you realize that with stormwater, you have so many constituents that end up polluting or creating problems for the receiving waters. So the constituents of stormwater include, but are not limited to, suspended solids, chemicals, hydrocarbons, cigarette butts, organic matter, as you have already seen, detergents as well. And then you talk of fertilizers in agricultural areas. But all these get trained and get transported, and then you end up affecting the aquatic life. As you can see, that the discharge normally is towards the receiving waters, which has biodiversity of life underwater. So how can we solve this? So you have some SUDS, which is sustainable drainage systems. Many of the SUDS options take up a larger volume or area of a site. So as you know, that developers are very cautious in how they distribute their site area. So their site is at a premium, particularly in urban areas. So with this type of system, you have, relative to maybe your detention ponds or retention ponds, you have a system which can carry traffic and also while managing stormwater in the process. So you talk of reducing the water quality that is generated for runoff, water quality being improved by depriving cross pollutants to go into the system, and then also adding to the biodiversity and amenity. So the top picture where you can see my cursor, you see PC is porous concrete, and then the other one with the letter B is PICP, permeable interlocking concrete pavement, and then you have porous asphalt, and then you have permeable interlocking concrete pavement, but this one with larger apertures, which is the openings that you see there. So this study was basically around trying to understand the failure mechanisms that we realized in South Africa. So for those of you who may not know the composition of PICP, this is just a schematic, or that's just the generic of the PICP structure. So you'll have, just like your pavement, normal conventional pavements, you have, for this one, you have your concrete pavers, you have your bedding, you have your grid in between, which will sieve out the cross pollutants, and then you have a geotextile there, which is optional. You'll see as I go along with the presentation why we say it's optional. And then you have the undertrain to the bottom there, which is also at times optional, depending on what you have. I will elaborate later on. And then you have the subgrade, and then the adequate edge restraints. So it's important that we take you through some state of PICP in South Africa. So we did some site investigations in about 11 sites, 9 in Cape Town and not necessarily in the city center, but in and around Cape Town, and also two in Gauteng, just to get a glimpse of having a winter rainfall climate and also the performance of summer rainfall climate of PICP. You can easily see here that there is deposition that is taking place because of this slope and this chute that is training directly on the PICP. This ends up creating blockage from the get-go of the PICP. In some instances, you have some inappropriate installations because this is a highly trafficked commercial center in one of the sites. So you realize that pavers have moved, have shifted, because you can see there's a weird pattern that you are seeing there because of the accretion movement of traffic. Also, it's a curve. And then a closer look, this is what you get. You have widened joints, and then the edge restraints are inappropriate because now you see the pavers are moving away and the edge restraints are falling away. So they are moving away from each other, which is not the core. The core is to ensure that you support the paving. And then in some areas where you have severe vegetation cover, which also like the leaves, the seeds, just by virtue of having a windy area in Cape Town, you end up having vegetation just, and also pollen, obviously, or in simple terms, organic matter just trying to trap the spaces between the pavers, which is called joints. And then you have extreme sediment exposure where you have your sand in one side, where you have sand just adjacent to the PICP. And then in some areas, you have a lot of grid that is missing because the anticipation or maybe the suspicion is that this has been pulled out as the vehicles traverse this section of the road. And then with that happening, you end up creating this situation where you have lack of grid. And then if the site owners do not recreate the area, you have some cigarette butts finding their way into the joints. And then in parking bays, you find that you have organic matter just trapped in the joints. And then in some areas, you have some surface clogging, which takes place in the form of sediment, and also a combination of sediment and organic matter. Fortunately, during the study, it rained, and then we were able to capture some interesting insight of what we saw in literature, that permeable pavement blocks from the edges of the permeable area into the interior. So this is an impermeable area, and then it trains all the way there. So you can see that that red boundary area has a little bit of ponding in the section. And then a closer look on the same side, you still have the same thing on one section, which is showing that there is a sediment blockage taking place on that end. And then at an exit or entrance of a parking bay, the same thing is applying because you have traffic bringing in some sediment that is being deposited, and also the slope of the site, creating all this. As you can see, just here by the corner, you have some vegetation, and you already see that as it's raining here, this sediment is just finding its way onto the pavement area. So some interesting findings from the study were about finding the different mechanisms of PICP that we found on site. Literature states that there is about one type of failure, which is in the first 30 millimeters of the paving block. So we termed it type 1 blockage. As you can see there, it extends to about 40 mils, but it varies, but on average, it ranges from 0 to 30 millimeters where you have your blockage. And then in some of the sites where we did some diagnostic assessments trying to understand the permeable pavement failure mechanisms, we found that some sites have a transition from type 1 to what we termed type 2, which I will show in a minute. So you have these sediments now being propagated or worked down by rainfall and vibration of vehicles as they traverse the area. So now you have an outline of sediment showing a silhouette of sediment on the pavers. As you remove the pavers, you can see that you have cigarette butts because they were already in the joints, and then you have this outline that's showing with sediment as well. From there, you have different designs. Like I stated initially, that you have different designs of PICP. You have one that has a geotextile, which is termed upper geotextile, just underneath the bedding layer. So some sites did not have that, but we do not see any evidence of blockage, which is simply saying that the sediment is being washed down into the pavement system and accumulating from the subgrade going up, or the bottom geotextile going up as well. Then some interesting finding is that we found in some sections where there's a geotextile, you have a type 3 blockage where the geotextile is being blocked in the section. And then where there is high traffic, like the one that I showed you, where the pavers are being dislocated from the original position of the design or installation, you have this geotextile being punctured. And then with this puncturing, it gets severe, where you end up having a type 4 blockage, where the sediment and some silt ends up finding its way into the geotextile and into the pavement structure, and then creating this system where you have clumps of mud and ultimately complete failure. So we discovered that we have 4 types instead of the one that is being reported. And then some considerations for design and construction of PICP. So indeed, as always, you can not always have the bad. We had the good as well, where you have some good spaced vegetation and then sufficient or adequate edge restraints where your pavers are still intact and there's no movement at all or dislocation. And then in some areas, we had good run-on and free of vegetation. So just to take you through what a run-on is. So a run-on, there's what you call a run-on factor, which is the ratio of a permeable area to an impermeable area adjacent draining a permeable area that drains onto this permeable area. And then moving on to the construction issues, you see this picture here is showing that there's construction taking place. However, there is no sediment trap. So by virtue of not having a sediment trap and having this section here being of permeable pavement structure, you have the permeable layers and then you have exposed sediment. You stand a chance of having a system having to go through premature layer blocking because you're already inviting through wind and also rainfall, you are inviting some fine material to find its way into the system. So we recommend, based on this study, we recommend that there are 3 types of PICP configurations. So you have a full infiltration system where you can have the same structure that you saw and the same layers, but now you have different layers. You have an upper geotextile, which is based on the design engineer's discretion, and also the lower geotextile, which is based also on the design engineer's discretion. So it's worth mentioning that the lower geotextile basically protects the subgrade from being punctured by the angular material that we use for the subbase. And then the top geotextile, at times it prevents the migration of bedding layer and also protects the underlying layers from that sediment that can find its way into the system. So you have a partial infiltration. So the partial infiltration, as you can see, you have an introduction of an undertrain there, because at times you find that the soil conditions are not good enough in terms of its infiltration rate, the soil in situ soil infiltration rate. Therefore, you end up introducing an undertrain so that you can limit the amount of rainfall that can be kept there. And then lastly, one recommendation is to have a no infiltration, like for instance, when you have expansive soils and then when you are very close to footings, say for instance, some standards, the ASCE standards state that you should have at least 3 meters away from the footing or the property structure so that you do not have that stormwater incursion into the footing. And then in slopes as well, we do recommend that you see, if you start installing PICP on slopes that are greater than 5 degrees, at the low point, you have stormwater at a low point overflowing. So in order for you to prevent that, we introduce what we can call check dams with protected orifices at the low point, so as to minimize or do away with this type of condition. Because remember, we are trying to manage stormwater, not attenuate stormwater and then allow it to leave to the surface yet again, but we attenuate and ensure that we reduce the amount that is being generated as runoff. So the other one is to have check dams with under drains on the side. Relatively, you can see this is about the same concept, but the other one is more transverse and the other one longitudinal as well. So then we talk of the maintenance considerations. We did try a couple of maintenance considerations of PICP. We had to introduce vacuuming using an industrial vacuum. So this was a wet and dry vacuum cleaner, 2000 watts. However, we were unsuccessful in order to pull up the sediment that was trapped in the joints. However, what is currently practiced in Cape Town, by then when we were doing the study, we used compressed air blowing, which this pipe, you fit an 8 to 10 millimeter nozzle, and then you align it along the grooves or the joints of the pavers. Then with the maintenance, you go to a site like this. I mean, it's worth mentioning, obviously, with the site owners giving us permission to do some work there. You go to a site, you find a block site like this, and then you start installing and ensuring that you have right precautions, your PPE, because you have flying material here. We devised a means of creating a shade cloth and a barricade so that everything can be kept within us, and then we sweep. So this is the type of drain material we would normally find. And then with the system that we employed, we realized that you couldn't go beyond 55 millimeters of the 80 millimeter block, removing the sediment or the joint material. And then from the quarry side, you come with a grid like this. However, you can just imagine if we were to put this back in, we're just going 2 steps forward and 1 step back. So basically, we remove the sediment that blocks, and then we introduce it again. So to prevent that, we washed it until we didn't find any color like that. I know it may be difficult to do that in the industry, but some quarries do this if asked. Then you have this grid, and then you start sweeping it in, and then the final product is there, as good as new, if you may wish. And then the key takeaways from this study is that PICP is a great such option. However, with poor design or maybe inconsiderate design and construction, which talks about the siting of the PICP and also unnecessary high run-on factors, which are greater than 2, you end up blocking the system. So, however, with good design, construction and maintenance practices, we can employ PICP and also see the benefit of making it quite a popular such measure in order for us to ensure that we use our premium space as well as developers and also different kinds of qualifications. So taking you through to the SUDS PICP guidelines, we have 2 volumes. This is volume 1, this is volume 2. They are readily available on the Water Research Commission website. This is the research report, and also this one is the guidelines. It's a very easy read. It's not more than 25 pages, so it has a lot of illustrations as well. So at this juncture, I would just like to appreciate the sponsors of this study, which was the Water Research Commission and also the University of Cape Town through international students and refugee scholarships. Thank you so much for your attention.
Excellent. Thank you very much, Motlatsi. So we're going to dive straight into Henk's presentation.
Good afternoon. My name is Henk Breunissen. I am located in the Netherlands, in a place called Gouda. Like said in the introduction, active all over the world with a main focus on the Netherlands and South Africa. I travel in and out of South Africa 6-7 times a year. So yeah, after this meeting, somebody wants to have a chat or meet up to talk about the solutions, then I'm available. I'm going to talk about sustainable water management, and we're first going to have a look at the challenges. So the first challenge we are looking for, and which we all suffer from sometimes, is the change of the climate, which has a big effect on water and water scarcity. So we experience a rising of average temperature, sometimes long times of no rain, or the opposite, very heavy rainfall. That gives a lot of challenges, so that then we have either too less or too much water. And the quality of the water is also becoming more and more an issue because there is pollution. And if we have to go back to the boreholes, you see that the quality of the boreholes are often not very good. So it also makes it very interesting to try to capture rainwater, which is a much better quality. The other challenge we have already for many years is, of course, growing cities and the challenges of keeping it livable for the people for now, but also in the future. We see problems with the heat stress, so the rising temperatures, and then especially on the hot sunny days, then the buildings heat up and the pavement heats up, and then even during the night it doesn't cool down anymore. Also, the consequence of all this is that we tend to put more buildings, more pavings, more paved areas, so there will be less water going into the subsoil, but instead it will be dispersed to rivers or channels and ending up in the sea, but not kept in the subsoil where it has a big value. So it's very important to look at robust water solutions and to see if there are opportunities to harvest and storage water, and especially to do that on site. So if you have a piece of land or a development for a building or extension building, then it should be that you try to keep the water in the same area as long as possible, or at least delay the discharge of the water. So if you're looking in formal situation, then you could say it would be required to have a zero discharge policy. And if you look, for example, at the SUDS 10,400, it already mentions things like it's not allowed to let the water run out from your area into neighboring areas causing problems. So you do have a responsibility for the water. Also, there's a stormwater management bylaws from the city of Johannesburg, also encouraging water retention. If I look at regulations in the United Kingdom or in the Netherlands, it's also pretty much based on zero discharge. So if you develop an area from greenland, which captures a lot of water and in a natural way, and it leaves the area in a slow pace or a natural way, the moment you put in buildings or pavement or other hard surfaces, the water will run off much more quickly. So there are regulations that say if you develop an area, the speed of the water running off from the area shouldn't increase. So this means this you can only achieve if you retain the water on site, temporary. What is a nice way to retain rainwater? The best way is to work with big areas and shallow storage. So then you capture a lot of water, which you can keep on site. If you do it underground, then it's out of sight and out of the sunlight. You see also a lot of places where eventually the water ends up in JoJo tanks or solutions like that. Then the water heats up, quality goes down. And why do you want to retain the water? It's not only to avoid problems with the people around you, but you can also give it a good use. That's one of the things you have to think about. So what purpose can you give the water? Well, for example, you can use it for cooling down the city or the building. So if you put like a water retention system on a roof, then the water on top of the roof already cools the building down. If you use the water for green plants on top of that, the evaporation will also cool the building and the surrounding. You can create green roofs in many ways. You can just do a simple grass, but you can even go further. You can do urban farming on rooftops. To support this solution, we figured out a capillary solution, which I will introduce later. And you can also think of other ways to apply the water into the building, like gray water solutions for maybe rinsing the toilets or other applications. So water has a big value, and if you start to think like that, you can also think, oh, how can I reuse it? So water retention. On this slide, you can see on the left side the situation without any retention. So the water comes on top of the roof or on the pavement, and it goes directly down into the sewer system, and the water is gone. With heavy rainfall, it will also cause a lot of troubles. We see, especially even in Holland, in the Netherlands, we see a lot of trouble when we have a big storm, and the sewer can handle it, so the water can block, and problems will occur on the roads or even in buildings inside. If we look at the retention option, then we can put retention solutions on the roof or under the pavement. So there are several places where you can retain the water, so which will reduce the amount of water that comes from the plot or from the area going outside. This retention system is based on a crate system. So this crate system, which is the black material you see, which gets wrapped in a geotextile to keep it open, so no dirt or soil will go in there. And then on top you can, for example, apply a substrate or a natural topsoil where you can put plants, for example. And the interesting part we added to this crate system is the capillary system, which allows us to pull up the water in a natural way. So with a capillary working system. So it goes up slowly into the topsoil, and the topsoil will take it to the roots of the plant. And the nice thing about the system is it works all natural. So there is no pumps or whatever needed. So it's a very kind way to do it. And it is also a very effective way of using the water for irrigation. Because if you would, for example, irrigate the water from the top, you will lose a lot of water during the irrigation process. Only 60% or 70% of the water will reach the soil because it has already evaporated while it's sprinkled. And then you will also have the evaporation of the soil itself. But in this way, you almost use 100% of the water. So this is another drawing of the same principle, but here you see again the buildup of the system. And what is important, that it also has a good drainage, because the natural drainage still works. So the rain will fall on top. Those are the light blue arrows. It will sink through the topsoil, go into the crates for temporary storage, and then if the top soil dries out again, it starts to suck up the water for the plants. So we can apply all kinds of solution on top of the crates. In this example, it's a natural, a green application, but you can imagine if you put the geotextile on top, you can also put sports areas, you can put artificial grass on top or play areas, because the crates are so strong they replace base material like a crushed stone. But you can also create parking decks for paving. Of course, then you have to put more material on top. You have the loading spread corrected. You can also think about running tracks. So there are all kinds of applications which you can put on top of it. I'm talking mainly about rooftops at the moment, but you can also build this system on natural subsoil. So you can also put it in your garden or in parks or wherever. The solution has the same principle. What are the benefits of this solution of proper water management on rooftops? The first thing is that you harvest the rainwater and you can reuse it, and you can make choices how you reuse it. One of the ways is to keep the rooftop green. But yeah, sometimes you have a red rooftop with other things on the roof, parking or walking areas or whatever. So then you can have other ways of reusing the water. The main benefit, of course, of retention roofs is that there's no direct outlet of rainwater. So you keep the water on site and you let it flow out in a slow way, in a speed you can control. And that can be done by mechanically, but you can also encourage that by software solutions, that it goes open and closes automatically. The other benefit is that it helps to cool down the building. So instead of having a roof with a waterproofing, which is often black or dark colored, which heats up the building easy, you cover it up so there's no direct sunlight on the roof anymore, but also the water will help to cool the building down. The other positive effect is if you put a green roof on it, the plants will suck up the water and it will start to evaporate the water. And evaporation, to evaporate water takes a lot of energy, meaning it takes away a lot of heat. That's why if you are in a city and you have a green park or you have trees, it's always much nicer to be there on hot days. A nice side effect is that if you cover the roof with a solution like this, you also protect the waterproofing underneath. Normally, it lies in the sun, has a big UV impact, but if you cover it, it will last much longer than it normally does. So some case studies, which are a combination of Dutch or South African. So for example, here, this is a park in Amsterdam. This used to be, this is on top of a parking garage in the front of a railway station. It used to be an area where the buses and trams came in with a lot of traffic, and they moved the buses away to another location and revamped the area into a green and walking area. So on the left side, you see the whole area covered with the crates for the water harvesting, and on the right side, how it looks at the end of the day. So you see on top of the crates, you can make all kinds of choices, either pavement or green areas or planks or whatsoever. This is another example. This is like a building complex. You see the apartments on the outside and the inner garden, the inner area of the apartments, which is on top of the parking garage as well. It's covered with the crate system and a foley, of course, to keep the water in. And it's redesigned as a garden. So people who live there can go into the area for relaxation, enjoying the plants, having time outside, but in the same time, we create a nice water storage at the same spot. So it's a nice combination. This is an example of a South African project. This is a rooftop in Cape Town, where we applied the same solution, but then on the artificial grass. This is a resting area for the F&B bank, where they, in the breaks, they relax, but also play some mini golf, stuff like that. So you can do all kinds of applications. This is another example of a green roof built in the Netherlands. This is also an apartment complex where they have also big problems with water and water storage and water leakage. So there we covered some parts of the roofs in between of the living rooms and the apartments, also with a water harvesting system, which also feeds the plants combined with the overflow, so there's always space to store new water in it. This is also a project in South Africa called Green Source, which we have been running for the last years. What is the Green Source project about? Actually, it's subsidized by the Dutch government. That's how it started, for Durable Drink Water Solutions Africa. And this project was granted to us. So the main goal was to collect rainwater, so that you see at the left at the bottom. And that is the base of the sports pitch. You see the top picture, where we put a nice fencing and boarding around it, so people can go and play there. And then we put, you see on the left side, a white container, and that comes with a water filtration system. So we can connect the water storage with the water filtration, so we make the water suitable for drinking water, which is available for the school, because often we located in a school, so there is also some governance for the location, and also for the surrounding people in the houses, for the village. We have done 18 of these locations so far in South Africa, all over South Africa. The project runs till 20, so we have still 2 more to go, and then we want to continue this solution in a more commercial way, because the subsidizing will be stopped, but the project will run on. After this, I will show you a small movie about the project, where you will see the process of building, but especially what is the impact of the project. But you must also realize what we do here outside on natural subsoil, you can also do it in the city or on a rooftop.
Rainwater harvesting, clean drinking water, and sustainable sports and play area. That is what the Green Source project is all about. The Green Source system collects rainwater. Its filtering units remove contamination. This way, safe water is provided for the surrounding community, and a place is created for people to come together.
The project has changed the lives of my kids tremendously, because remember, like I told you, they were playing on sand, like pure sand. Now, for the first time in their lives, they are experiencing an artificial turf. Before this water purification system, everyone in this community can attest to that. Water in Rustenburg, it's not clean. I must say, it's not clean, because even at our households, we are buying purified waters from the stores. Ever since this water purification system was installed at my school, one assurity that my learners are drinking clean water. We are using it for cooking at the NSNP kitchen. We are assisting the community also with clean water.
We learned about the Green Source last year. Yes, because my 2 children attend the school there. It's helpful because the water around here is not that drinkable. Yeah, but the Green Source is helping. Yeah.
I can see that the rate of absenteeism due to sicknesses has reduced a lot. I really believe that it is also contributing positively towards their health.
Here in Boshoek, we don't have water from the municipality. So all the water that we have here is from underground. And then we are surrounded by mines and all that. So I think before, learners used to get sick because of this water was not clean. But now the attendance it's high because of that. So they can consume clean water anytime.
It was very nice that After installation, my educators went on a training. After being trained, that's when they were taught about how this water, the dirty water is disposed. So we have captured it in a green Jojo tank. So from this tank, the disposed water now goes straight to the garden.
Our continent. What about Imperi?
So, developing them holistically, we need a ground like this one, so that learners, those who are not performing academically, at least can benefit by being developed from this ground. So, do you see how this thing is answering or is responding to the vision and mission of our school? Yeah.
Okay, this is also the end of the presentation. So thank you for listening.
Great, thanks, Henk. That was very interesting. So we're going to move on now. I think the next slide up should be let's have a conversation. So let's dive into the questions, because I'm sure there's quite a few from the audience, particularly on both systems. So I think I'd like to start with one for you, Henk, particularly on that video in the school. We do a lot of school work in rural areas, and I'd really like to find out a little bit more about the makeup of that project in terms of the composition of the build-up and the durability of the actual turf layer on top. Is that a pure synthetic, or is it a combination hybrid?
Thanks for the question. In this case, it's 100% artificial grass.
Okay.
But you could easily change it to a hybrid solution as well. But that is a technical thing. Yeah.
And what sort of durability or lifespan would you expect from a system like that under those sort of daily usage conditions?
Well, the oldest one we have now is, I think, 7 or 8 years old, and it's still working, not in perfect shape, but it's still working. But the artificial grass pitch should at least last for 10 to 12 years. And the base material can stay. I mean, you just have to replace the artificial grass.
So it's just a question of retopping it. And then I assume that topping is recyclable as well.
Yeah. Well, we're moving that way. There's still a lot to learn, but it's a big development going on to make artificial grass more recyclable than it is now.
Okay, excellent. So I'd like to open it up to the floor. If there's any questions, let me not hog the presenters here. Oh, there we go, Marty.
Thanks very much for the interesting talk, guys. On the permeable paving, on the first section of the talk, can you rehabilitate, paving that kind of hasn't been done that well, or you literally need to relay it and then, try and fix it? And, in terms of removing and putting in the fines and all of those sorts of the clean, very fine grit, if that's the right way to describe it. I mean, in terms of converting an existing paved area into a permeable paving area, is it actually economically viable, or is it only viable if you start off with that as the plan from scratch? I was just sort of wondering if that came into any of the studies.
Motlatsi, that's one for you.
Thank you for the question, Meti. So you can convert the system from conventional to permeable pavement. However, you'll have to take note that you have to really take note and respect the housekeeping rules, like ensuring that your system is installed in low traffic areas, and also ensuring that the maintenance is on point, because I think the core problem with this system is the maintenance. However, trying to address the issue of the economics of the system. Like, for instance, if you have a green field and then you start having an impermeable or conventional pavement system, you find that at times the municipal systems or the main stormwater lines are not really accommodating your system. So ultimately it's going to mess up the system somewhere. So you end up flooding. So I think it's more of a trade-off to some extent. But I would recommend you use the permeable system, but taking right precautions.
Yeah.
Thanks.
So I mean, we've got a open parking area, I don't know, probably 20,000 square meters or so, which has been done with normal interlocking pavers, etc. But we did, as part of our approval, have to put attenuation ponds, etc. And I'm just trying to understand economically. I mean, the serviceable life of the whole parking area was on the basis of a 5-year design. It's already exceeded that, but the amount of traffic it's taken is a whole lot less. So I'm just sort of, trying to think high level. If someone wanted to, I mean, and the main reason that we used paving blocks was so that if that got redeveloped, we could take those paving blocks up and reuse them, as opposed to using a tar system. And, we wouldn't be wasting as much. But whether it would be possible to actually use that to gather all the water that's falling in that area, as opposed to it being in the attenuation ponds.
Yeah, no, it won't really. I think the issue here would be that issue of the run-on. So the acceptable run-on factor is 1:2, meaning 1 part of permeable to 2 parts of impermeable. Once you start having more than that, then you start making the system to not be economical, because you'll have a frequent routine maintenance.
Yeah.
So yeah, I think that is what you need to consider.
Yeah, so you're almost creating like gutters in your open paving area, where possibly, only where the cars park or something like that, not where they're busy driving.
Yes, because once you start having where they are busy driving, you have a condition where you have, as you saw in one slide, the geotextiles get damaged, and then you have all the fine materials propagating to the bottom.
Okay. No, thanks. It was very interesting.
Thank you so much, Martin.
Just adding to that as well, I think one of the key sort of benefits of SUDS is that they can actually be used in combination. It's not just a one solution. So you can use permeable paving. If you look at some of the products from our sponsor Geoplast as well, in terms of their subterranean storage, and you look at some of the presentations that Henk has done, there are a lot of opportunities to combine different systems where you can have sort of grassed SUDS running down between bays when you've got nose-to-nose parking, and using the vegetation and using some subterranean storage to attenuate and absorb. I mean, if one looks at some of the international studies, there's good evidence that a lot of bacteria are actually able to break down some of the hydrocarbons that get washed into those systems and prevent them from actually landing up in water courses. So looking for hybrid solutions definitely offers a lot more flexibility than just trying to adapt one particular solution. I think in most instances, a treatment train, as it's referred to from a SUDS perspective, is a number of different solutions. So you could start with a green roof. That green roof could discharge onto permeable paving, and there's a cascade of benefit that impacts the site all the way down until that water eventually leaves the site or recharges the groundwater.
Yeah, no, awesome, thanks. And then maybe just a second one, if I can, quick. I mean, we've got a section of the property that is potentially going to become a sports and recreational area. So again, I think you called it water source or energy source. Sorry, I can't remember the exact name, but I mean, it was the most incredible thing to, I mean, has that ever been done like on a cricket field sort of size of field, or just these sort of smaller soccer fields? And that's then to Henk.
Thank you for the question. Now we have done this already on big full-scale sport pitches. So full-scale soccer and hockey pitches on this side in Europe. So that wouldn't be a problem.
Okay, no, cool. Because I know cricket obviously is, I think, the biggest field that you can have for a sporting activity. And I know there's also normally a lot of drainage in those cricket pitches already. So it might be almost a combination of what they need for their drainage, but actually using it to capture the water as well. So
yeah, the system is actually also the drainage.
Yeah,
that's the reality of it.
Yeah, thanks.
Okay, great. Then we had someone else's hand up. There we go, Mike.
There, thank you. All right. Yeah, my question is to Henk. I was very interested in the Green Source project. And as I understand it, the football field acts as a large catchment area. The water is then caught in that capillary system underneath it. And then it's treated much of it is treated as to be potable water to be used by the community. What treatment filtration system is used to make that water potable?
Mike, thank you for the question. We make use of an ultrafiltration system combined with a sand filter and a carbon filter.
Thank you, Henk. Thank you.
Okay, moving on, Mr. Malapani.
Thank you so much, sir. From Mr. Motlatsi's presentation, from one of his slides, I saw that there was sort of a pavement
A layer works build up.
layer works build up. So I just want to know if there's a preferred layers arrangement that goes with this permeable pavement, or is it going to differ based on the ground conditions and the expected traffic, or what?
Yeah, Motlatsi, I'll leave that to you.
Okay, no, thank you so much, Mr. Malapani. So the particle size distribution, or maybe the stone size distribution of the pavement layers, is governed obviously by your traffic loads, and because of the different depths that you may need to have in order to sustain your traffic loading. And then also the sizing has to talk to the porosity that you will have to design for, so that you know the picking of your stone or your pavement layers. Thank you.
Yeah, I think just to add to that is to note that it is definitely a different layer works build up to a conventional road system. Most conventional roads layer work systems don't like water in them at all from a long-term durability point of view, whereas permeable paving sub-layer works are specifically designed with certain aggregate sizes and porosities to allow that infiltration and to maximize the void volume in that space.
Thank you so much.
Okay, and then just as a general note, we have a fairly broad cross-section of architectural and engineers on the call. So in the chat, I've actually just posted a link to a new urban stormwater design flood estimation modeling paper that was published by the WRC last year. It really does give you a good nuts and bolts. You may be terrified by some of the formulas if you don't work with a lot of engineering formulas, but for the engineers in the audience, or anyone interested in flood determination and some of the intricacies in sort of the latest thoughts in flood modeling, definitely something to look at, because again, this goes hand in hand with the overall SUDS approach, where it's not one size fits all. It's a combination of using different initiatives, and this encompasses architecture, landscaping, engineering. I think all too often historically it's been left up to the engineer to throw as much water as possible into a big grey pipe and get rid of it as quickly as possible. If one takes a walk along most of the Spraits in Johannesburg, you only need to look at the extent of erosion on the banks of those. Most of them have either been undercut or eroded completely vertical, which is an indication of the volume and the velocity of water that's hitting those natural water courses because of the increasing densification. We have a situation where you had a 10,000 square meter property in Breunissen that had a house and 9,500 square meters of lawn on it. Now all of a sudden you've got 400 townhouses. So it's a very different runoff coefficient. And that's what designers need to be cognizant of in the way that they approach designing. I think for all too long, the Joburg Roads Agency standard has been, pop an attenuation pond in the lowest point of the site and be done with it. But I think there's a lot more opportunity to intelligently look at how to preserve water on site as long and as best possible for the benefit of that site. I mean, it's getting to the point in some countries now, in certain US states, it's actually legal to capture your own rainwater because that rainwater belongs to the state and has already been sold as part of a water use license downstream. So I think Colorado is one of them where it's illegal to buy a JoJo tank. And then from your side, Henk, just looking at the solutions that you proposed, I think just to make everyone aware that that's obviously a very scalable solution. What we've seen, particularly in Europe and the US as well, is the development of sports infrastructure on land that's potentially subject to flooding. So to maximize the utility of that land, you can look at a hybrid solution where you can have sports fields, but those sports fields are actually able to act as storage and attenuation facilities under extreme flood events as well. Henk, do you maybe want to elaborate on that if you had any experience with some of the larger regional flood type sports facilities.
Yeah, that's a good thing that you add that to the discussion. We have done several sport facilities, tennis courts and playgrounds in what we call areas that can be flooded on riverbanks or low areas where the water will rise the moment you have a lot of rain. And they were allowed there because they don't block the water capacity a lot because it's 90% hollow. And actually it works quite nicely, is our experience.
Yeah, no, I think the case studies I've seen as well have been very much in that in that vein. Again, thank you very much to everyone involved. Upcoming events, we've got the biophilic case studies in May, June 2024, still to be confirmed. There's always sponsorship opportunities for anyone in the audience that's looking for some exposure. Then again, thank you very much to our speakers, to Henk Breunissen and to Motlatsi Monyake. Thank you very much, gentlemen, for a very interesting conversation. And then again, a huge thank you to our sponsor, Geoplast, Building Beyond Together. Like I say, I encourage you to go and have a look at their catalog. I think you'll find some quite interesting solutions that may change the way you see water storage and subterranean water storage options, facilities. And feel free to reach out to Henk and Motlatsi. I think Henk, there's a lot of opportunities looking at the amount of schools work that's been done, particularly in rural areas in not only South Africa, but in sub-Saharan Africa as well. So thank you to Geoplast. Become a sponsor. Don't forget, need all the help we can get to get the message out there and keep the Regenerative Collaborative on the radar and pushing the agenda. Don't forget to follow us on the social media channels, LinkedIn, YouTube. Bookings are handled on the Eventbrite platform. So thank you very much for attending, everyone. Thanks, everyone. Thanks to our speakers, sponsors. Have a good evening.
Thank you, everyone.